Hello, AP Scholars. Once again, I am not here. Sorry about that, but we will continue moving forward. I heard some people were having troubles with the assignment, so I thought I would help out with some of the things we've been working on and see if we can make things make a little bit more sense. And also, a little bit later in the video, I will talk a bit more about the next steps of the project, such as reducing fractions and such. So I just wanted to first talk about opening things. Really, that's harder to do. Oh, it's like down here in this tiny window. Okay, cool. It's very tiny. There we go. We were talking about making mutator methods in the last class, and there were some questions on that on the Facebook group. Thanks so much, Will, for asking that question. So I just wanted to bring your attention a bit more to it. Mutator methods are all about changing the instance variables. So we can make all of our mutator methods that are also known as sort of the getter methods is actually the term. Setter methods. There's getters and setters. I'm not making this up. This is industry terminology. Getters are the accessor methods. They get the value for you. It's a one direction. You see what the values are. Mutator methods are the setters. So that you set the value. So you change the value. And the reason why you do that through a method is so that you can police the values that the client code is trying to set. So for example, when we go to set the denominator, we can protect it from becoming 0. So an example of, this is on the Facebook group as well if you want to see more discussion on it. A mutator method for setting the numerator would look something like this. It would be public. Mutators are meant to be public for the most part, especially the ones that are designed to set the values. They give a channel of access to client code to manipulate those values. So they're most likely void, or they don't have to be, but in this case they definitely are. Set numerator. And they're pretty straightforward. You just send them a parameter. We'll call it n, for example. And then what do? Well, they just set your instance variable. I'll use this dot n to represent, the n that is the instance variable, to whatever parameter you send it. And we don't have to do a lot of policing in this case because the numerator can be whatever number you want it to be. Public void set denominator. Well, we'll send it a d, and here we need to be a little bit more careful because what if they sent a 0? So then you would also do, take the instance variable that represents our denominator and set it to our parameter, but we would only do this if it was not equal to 0. So there's an if statement to write here that's pretty trivial that you could add in. So I'll just leave that. If d does not equal 0, something along those lines. I'll leave that for you to finish off. And of course, we should probably test these things and make sure they work. So how would you do that? Well, it's all about your, I don't know what to think about that. That's all about your fraction tester class, right? We wrote this main method. So you could take one of your many fractions you've created and call that method, set numerator to 11, and then, print out F6. And we would see if it turned out to be 11 or not in the numerator. And you could test out the set denominator to 0 and see if your code, manages to prevent that from happening. And you probably should spell denominator right. Denominator. There we go. And also, set a perfectly valid. Set denominator to 11 as well, and check if that works. And of course, each time printing out what your fraction has become afterwards so that you can verify, did that in fact work? Do we see the change that we expected to see? And do we see the safeguards work as we expected them to work? You might want to put in a, so just go back to this tiny thing. you might want to put in some kind of print line statement if it fails, like we did here. Some kind of error message, just so that we can see some confirmation that the error checking was successful. The next bit of mutator methods you're going to write are the arithmetic operators: the multiply, the divide, the add and subtract, and that's adding, multiplying, all that kind of stuff with fractions is stuff you know how to do. But in this context, we're designing methods that will do that, and I have a specific way that I want you to do it. I even shout out that it's not necessarily the best way, right here, not necessarily the best design for these functions, but they are going to illustrate mutator methods quite effectively. And later on, we'll explore some alternatives because, we could do better. This is basically how they're going to work. We talked about a bit of that in the last video. I'll go into more detail right now because I think some people are looking for that. So we'll go to our tester class for a second, and this is basically how it should work. Let's take, we'll make a new fraction. I'll call it f, I guess we're on 7 equals new fraction, maybe 1/3. And we'll make another one, fraction f8 equals new fraction, 3/4, 3/4. And what we can do is we can multiply them together. So the way that the assignment describes it is that you'll write some multiplication method. We'll call it mult, M-U-L-T. And the way you use it is you would say you want to multiply f7 and f8. You would do f7 dot mult f8. And this will be a mutator method that will change the value of f7. So f7, after we do this line of code, will contain the product of f7 and f8. So f7 will no longer be 1/3 after that. And f8 will still be 3/4, but the answer will get put into f7. And so therefore, this is a mutator method because it's changing the instance variables inside of the object from which you're calling it. There you go. That's like the definition right there. So how does that going to look? I start with multiplying because multiplying is about as easy as it gets. So it would be, another public void. It's not returning anything. It's changing the values inside of the object, the state of the object. Mult, and then it takes in, what does it take in? Well, it takes in another fraction object. Fraction f, we'll call it. So fraction f is what we're multiplying, and we can basically just multiply numerator with numerator and denominator with denominator. Do we have to worry about things being 0 in here? It turns out no. We don't have to worry about a 0 denominator in this fraction class because there's no, or this fraction object that we're getting sent, because there's no way to make a fraction that has a 0 denominator. So we can assume that f, whatever it is that gets sent to us, because our constructors do their job so well, that it will never have a 0 denominator, and then we don't have to do any additional error checking. So error checking sort of begets error checking, or no, actually it's the other way around. Error checking early on prevents or makes redundant any other additional error checking to an extent. We'll see that in dividing that's not true, but you could probably kind of foresee that, but we'll talk about it. So anyways, we're a mutator method, right? So we're going to change our, our instance variable n by multiplying it onto fractions n. So we do times equals, f, what? How do we get f's numerator? Well, actually, I don't think I've written it in this example one, but you have an accessor method called get numerator or something along those lines, right? So you could do that. This would be a great way to multiply n, your numerator, by f's numerator. There's another way you can do it as well. Check this out. You could do f dot n. You can directly access the numerator of f's of the fraction f. And you might think, wait. No, you can't. That's not allowed because these are private. You cannot touch those. But this isn't client code. This is inside of the class. So a fraction can access the private instance variables of other fractions. So that's a very important thing. You might actually want to take note of that. It's a nice little edge case where you can see some tricky multiple choice questions trying to get at you. This is not an error to access directly a private instance variable as long as you're within that object's class as it is. People still tend to use the accessor methods because they can take advantage of that built-in error checking that might be supplied, or whatever streamlining that might be supplied by them. Our get numerator and get denominator, not very special, so it's your choice how you want to do that. Of course, the same thing with the denominator. We're going to multiply our existing denominator with the fractions denominator, and the same rule applies. I could access directly that private instance variable with f dot d. F's denominator is private, but we're in that class. But you know what? It's probably a good habit to use the code we wrote to access those things. So that's how we do it. The final step is that we need to reduce this. I think that is something that will be a little bit tricky, but we'll take a look at the algorithm and see. But that is part of the assignment: is your mult, your divide, your adding, your subtracting. The answer should be in lowest terms. So the next step is then to reduce the fraction, and I'll point you in the right direction. Fraction. There we go. Point you in the right direction. Basically, you know how to do this. This is something you've been doing for a while. How do you do it in Java? So first of all, you want to find the greatest common factor between the numerator and denominator. And then you divide your numerator by the greatest common factor, and you divide your denominator by the greatest common factor, and voila, your fraction is in lowest terms. So how do you find the greatest common factor? So there's something called Euclid's algorithm, which is pretty spectacularly old. It's like thousands of years old, and I think, actually, you could Google this. You could find out. I read at some point that this was the oldest algorithm in the world that's still in use today. So I'll put that rumor out there. I'll verify it some other time, or maybe you can verify it. I wrote it in the assignment, it appears, so I hope it's true. Anyways, how it works is basically if you have two numbers and you want to find the greatest common factor, Euclid discovered thousands of years ago that if you take the two numbers, you take your two numbers and you subtract the smaller one from the larger one, the greatest common factor between these two numbers is still the same as the greatest common factor between these two numbers. Wow, so you just keep on going, all the way down, until you get the numbers to be the same. So you keep on repeating this process, right? So now I'm going to subtract 105 from 47, and then, oh, look, I find the smaller one. I'm going to subtract 42 from 105, and I get this number. 42 is still smaller, so I subtract 42 from 63. Keep on going, and eventually you get to the numbers are the same. And if there is no greatest common factor, you'll at least get to 1, between two numbers. So that'll work out at one way or another. And you can do this in Java just by using a while loop to repeat this process of you get two numbers, while they're not the same, just keep subtracting the smaller from the larger one. So you're gonna have to evaluate that. Math.min is a good way to compare the two values. You could just use the greater than or less than operators as well. It's pretty straightforward. So that's how you're going to write this method to find the GCF. And that's going to be a helper method. That's going to be our first helper method. Technically, you could make it public. There's no reason you couldn't, but we'll make it a helper method just to indicate that, hey, we're going to keep that sort of our interface clean. We don't need people to use that. So we're going to make a private, I guess it's going to return an int find GCF, or whatever you want to call it, really. And that's going to take two numbers, int A, int B. And it's going to return whatever the GCF between the two is. So this will be like a while loop. And at the end, you're going to find out what it is, and you're going to return, GCF. You're probably going to, make that. So I'll zoom down a bit. You'll probably start with a GCF variable, and a while loop will, do that algorithm, Euclid's algorithm, until at the end you find what it is, and you can return that. Actually, I guess at the end you don't really need that. A and B are going to get reduced, so you could just return A or B at the end of that algorithm. Would probably be more efficient. Yeah, I know there's a bit of a mystery how to write that, but that's fine. So if we have a find GCF, you just do your best to work on that. We're just going to get the GCF. You can say int GCF equals find GCF and send it the two numbers, the numerator and denominator, and then you can divide n by this GCF and d by the GCF, permanently, and store those values. And hey, there you go. Mult has now reduced the fraction. So that's the basic process of that. You'll be doing the same sort of thing for your divide and your add and your subtract as well. So that works out nicely. So multiplying, that's how it works. Dividing, I guess I shall go here. Dividing is the next one to do. Where is it here? Yeah, dividing is just multiplying, but in reverse. So you're multiplying by the reciprocal. So you just multiply the numerator by the denominator of the other fraction, and you multiply this denominator by the numerator of the other fraction. And there's where you could get into some trouble. The numerator of the parameter fraction might be 0. And you'll have to do some error checking to make sure you don't end up with a 0 denominator, because you're effectively dividing by 0 at that point. So that's some error checking that will have to be put into the dividing method. And then adding and subtracting are a little bit harder, as you know, because you have to get the denominators to be the same before you can add the numerators together. Don't write some fancy algorithm to discover the lowest common denominator. Just do it like the laziest way possible. If you're adding, just multiply the opposing denominator by like the most simple way that you can find. You don't have to necessarily already have it in lowest terms when you go to add things together, because you're just going to call that reduce. You're just going to do the reduce code anyways at the end of it. So don't spend too much time trying to make really pretty fractions. You're adding them together, and I think, or subtracting for that matter. I think it'll work out nicely. And then that's basically the end of the code. That's it. That's the assignment. We're gonna next class take a look at making our using this and making our little quiz game. So if it's not working for next class, then you'll have some troubles continuing on with the second part of the project. So please ask lots of questions in the Facebook group. The person who was in for me said that there's some people that are doing great and some people that were struggling. So if you're struggling, put something out there on the Facebook group, or email me. It would be fine. Just get in touch and try and make sure that happens, because I know it sucks that I'm away, and hopefully you're not feeling too sad about that. But if you can, then you'll get ahead if you can ask that question. All right, thanks everybody. Good luck today.